Hello there. In this one of my last videos, we're going to look at solids, covering A star and A grade A topics. And without further ado, let's look at a question which involves both a sphere and a cone. Let's say we have a sphere here. Let's make it a sphere of plasticine. And somebody wants to make a cone. They want to make a cone out of that same amount, using every bit of plasticine. And the cone is going to have the same radius, that is 5 centimeters, and they want to work out what height the cone would be. Well, how do we go about this? Well, first we work out the volume of the sphere, and we look in our formula sheet and we see that the volume of a sphere is 4/3 times pi times r cubed. Had to have a cube there, so we'd have cubic units because we're talking about volume. So let's work that out first. So we have 4/3, whoops a daisy, incompetent as ever, 4/3 times pi times 5 cubed. And the answer is 500/3 pi. Now we're going to leave it like that rather than as a decimal, because that's the exact units. Now, that's the volume of plasticine we've got. Now we're going to see try and calculate the volume of the cone. Now the volume of a cone is, the formula's in the book, volume of a cone, it is 1/3 pi r squared, and that's the area of the base, times the height. Now the height we don't know, so we're going to come back to that. So let's have a look. The volume of the cone equals 1/3 times pi times the radius squared times h. So let's work that out. 1/3 times pi times 5 squared. So clear that. 1/3. Sure, some of you can do that without a calculator. Times pi times 5 squared equals, there we are, 25/3 pi. So it's 25/3 pi times h, h being the thing we're trying to find. Notice how I worked out the first part of the formula, and then I had to multiply that by h. Now, all we have to do is equate the two. So let's have a look. So we've got, here's the volume of the plasticine, 500 pi/3 centimeters cubed. All the units are going to be centimeters cubed, so I don't need to put the units in, equals 25 pi/3 h, the thing I'm trying to find. Now, how do I find out what h is? Well, I divide this, the exact answer for the volume, I divide it by 25 pi/3. So let's do that. So 500 times pi all over 3 divided by 25 times pi all over 3 equals, and there we have it. The answer is 20. H equals 20. Does that make sense? Yeah, if h was 20, 20 times 25 is 500, so we'd have 500 pi/3 equal to 500 pi/3. Right, let's just pause there and now look at another solid question. So, in this solid question, we're going to try and calculate the surface area of this square-based pyramid. Now, fortunately, it's square-based, so each of the 4 triangular faces is going to be the same. Now, the problem is this. This triangle, if I was to go to the side, you'd see that this triangle here is slanting, this yellow triangle. And I need to try and work out, what this length here is. The slanting height of the triangle. Make that diagram a bit better. Right, now to do that, I need to use a bit of Pythagoras. Let's have a look. I know that the vertical height of the pyramid, this length here, I'll just make it a bit clearer, is 6 centimeters. Now, I need to work out this length here. It's square-based, so there's a symmetry about it. So this green length here must be half of 5 centimeters, must be 2.5 centimeters. So to find the slanting height of the yellow triangle, I'll use Pythagoras. X, that'll be the slanting height, equals the square root of 6 squared, that's the vertical height, plus 2.5 squared. Why plus? Well, I'm trying to find the longest side. I'm trying to find the hypotenuse. So let's get my calculator out to do that. So square root 6 squared plus 2.5 squared. And there we have, it's 13/2. Now, I've not quite finished, but I've probably picked up the most, quite a few marks here. Method I've employed, and accuracy mark as well. Now, let's work out the area of the yellow triangle. Area of a triangle equals a half base times height. So it's going to equal the base of this slanting yellow triangle is 5. And the height we just worked out is 13/2. So I'm going to type in a half times 5 times 13/2. Get my calculator to do all that. So it's a half times 5 times 13/2. Oops, a daisy. Syntax error. Let's try that again. A half times 5. That's the base of the yellow triangle. Times 13/2 equals 65/4. And the units be centimeters squared. But there's 4 of these yellow triangles. There, one on the right, one on the left, and one at the back that we can't see. So I multiplied that answer by 4. But I've not quite finished, because I also, if it's after the total surface area, I've got this square here that it sits upon to add. So it's going to be 65/4 plus 5 squared. And we'll get the calculator to do all of that. There we go. If you're fortunate and haven't been fiddling around with the calculator, you should still have the previous answer up. So I'll do that times 4, add 5 squared, press the equals button, and I should have, there we go, and the units be 90 centimeters squared. Okay, one more. I know this is going to make this video a bit longer. Sorry about that. Just pause. Right, and the last one to look at is the surface area of a cone. A cone really is a circular base pyramid. Now, before we go and answer the question, let's have a look what we get in the exam paper. On the second page, here we are, the curved surface area of the cone. That tells us how to calculate all this. That is the curved surface area of everything except the base. More about that in a moment. And the formula says this. It's pi, r, and L is the slanting height. So let's go back to our question here. So we're going to work out the curved surface of the cone. And for that I need the radius, which I've got here. But I also need to know the slanting height of the cone. I don't know that. Just remind ourselves the formula is pi times r times L. Well, again, I use Pythagoras. Here we go. There's a symmetry about it that suggests that this length here must also be 8 centimeters. So if I use Pythagoras, L, the slanting height, is going to be square root of 9 squared plus 8 squared. And I'll probably leave that in surd form. Let's just work that out. Square root 9 squared plus 8 squared, and it's equal to the square root of 145. So the outer curved surface, to find the area of that, all I do is bung in. That's very technical language I'm using here. I bung in the values. So it's going to be pi times the radius of 8 times root 145. Let's move that over here so you can see the exciting action of somebody pressing some buttons on a calculator. Shift times 10 gives you pi times 8 times root 145, and there's the answer, 302.6 to 1 decimal place. But I haven't answered the question. If it asks for the total surface area of the shape as opposed to just the curved surface area, I'd also have to calculate the area of this circle and then add that on, which would be, so the area of the circle is going to be pi times 8 squared. So I'd add that to my previous calculations. That plus shift pi times 8 squared gives me the total surface area of the shape, which is 503.7 centimeters squared. Okay, I hope this, sorry about the length of the video, but I hope there's been some use. I've given you a quick resume of all the solid type questions you might get. Thanks for listening.